Welcome to, let's see, question 12 from chapter 3. So let me solve this for you. So I've got everything, I've got the skeleton created. Now I just need to put in all of my numbers. So the objective function here, so I've got, I should say, here's the economy, the standard, and the deluxe. I want to maximize my profit. Profit per unit is 63. 95, 135, placeholder. For my choice variables, my objective function is the sum product of these parameters and my choice variables. All right, my constraints for the fan motors, 1, 1, and 1. Cooling coils, 1, 2, and 4. Time, 8, 12, and 14. And these all have to be less than or equal to, you only have 200 motors, 320 coils, and 2,400 hours. All right, so what do my constraints equal based on my choice variables? So, get my sum product function and choice variables, parameters of the constraints, anchor, copy down. All right, now I am ready to solve this problem. Okay, so the objective function is that I want to maximize that by changing these three cells, subject to these three constraints all being less than or equal to these three numbers. Non-negativity, simplex, solve, answer, sensitivity, limits, hit OK. All right, so in order to maximize my profit, I want to produce 80 economy air conditioners, 120 standard air conditioners, no deluxe air conditioners. And if I do that, I will maximize my profit at 16,440. That was part A. Part B, which constraints are binding? These two, fan motors and cooling coils. Again, I know that because it's strictly equal. Now you can always go back, and I've said this before, just look here, those two are binding. Which constraint shows extra capacity? How much? The time constraint, right? That's not binding. How much? The 320. Now you could also just go back here and say, okay, 280 is less than, 2080 is less than the 2400. Ergo, take 2400 minus 2080, and there's your 320. So either way, I don't care. All right, so we've got an extra 320 units of hours. Finally, if the profit for the deluxe model were increased to 150 per unit, would the optimal solution change? Use the information, okay, use your information. So to get that, you want to go to the sensitivity report. All right. If the profit for the deluxe model were increased to 150, okay, so here's the deluxe model. Right now, the profit is at 135 per model. I can increase the profit. I can increase the objective coefficient up to increase it $24 and still not impact my objective function. So is that within the range? So I can increase it up to $159, and I would still have no impact on my optimal solution. So no, increasing the deluxe model to 150 would have absolutely no effect on the optimal solution. And just to show that to you, why don't I just go in here and make this 150? So our optimal solution was 1644. I'll just put that here. I'll run solver again. And now that I got the 150 changed, solve, right? Nothing, right? These two numbers are identical, right? So, that's the whole point of looking at that sensitivity report. You can increase the deluxe model to 159 and the objective function will not change. I can increase the standard model $31 and my objective function will not change. I can increase the economy profit per unit $12, it will not change. And then here's the same thing. I can take the deluxe model down to negative infinity and the objective function won't change. Now, the reason for that is because I'm not selling any of the deluxe models. So I can go down to 0 or I can put in a negative number and nothing's going to change. And I can even give you, check this out, let's say negative $1,000, right? And run solver again. Now with this new parameter, run solver. Voila, doesn't matter. Why? Because I'm not using any of the, I'm not producing any of the deluxe air conditioners. All right, well, there you go. There is problem 12 from chapter 3.